Alright, lesson 5.2 is about bisectors and triangles, and our objective is to use properties of perpendicular bisectors and angle bisectors. So there are a few theorems to start off with. Theorem 5.2 is the perpendicular bisector theorem. It states that if a point is on the perpendicular bisector of a statement, then it is equidistant from the endpoints of the segment. Okay, so that one says if it's on the perpendicular bisector, it's an equal distance from each endpoint. Theorem 5.3, the converse of the perpendicular bisector theorem, says that if a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector of the segment. So the first one is saying if you know it's on the perpendicular bisector, then you can also say that it's equal distance. The second one is saying if you know that they're an equal distance, you can say that it's on the perpendicular bisector. Okay, theorem 5.4 is an angle bisector theorem. If a point is on the angle bisector, then it is equidistant from the sides of the angle. Five is the converse of that statement. So the 5.4 said if we know it's on the angle bisector, then we know it's equidistant from each side of the angle. 5.5 switches it around. So it says if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the angle bisector. So this one is how to figure out if it is on the angle bisector. Okay, then we have a distance. So the distance from a point to a line is the length of the perpendicular segment from the point to the line. So it has to be perpendicular. So like here they make 90-degree angles when they're finding the distance. So in this one, point D is 3 inches away from side AB and side AC. Okay, let's take a look at some examples. So this first one is applying the perpendicular bisector theorem. Use the map of Washington, D.C. to describe the set of points that are equidistant from the Lincoln Memorial and the Capitol. So, the converse of the perpendicular bisector theorem states if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So that's just restating what we wrote down earlier. That's not new information. a point that is equidistant from the Lincoln Memorial and the Capitol must be on the perpendicular bisector of the segment whose endpoints are the Lincoln Memorial and the Capitol. So this one is saying that we know these 2 points are equidistant. What does that show? That shows that they're on the perpendicular bisector. So any points that are equidistant from the Lincoln Memorial right here and the Capitol are on the perpendicular bisector, so like somewhere in here. Those would all be equidistant. Okay, number 2. This is where we're actually doing a little bit of math. Using the angle bisector theorem, find x, FB, and FD in the diagram at the right. So, notice, this angle is congruent to this angle. That means this has to be the perpendicular bisector. Or the angle bisector, excuse me, because it cuts the angle exactly in half, which means that this side and this side are equal. FB equals FD by the angle bisector theorem. Since we knew that angle was cut exactly in half, we know those lengths are equal. So then it's just substitution. FB is, I should write these the other way. FD is 7x minus 37, and FB is 2x plus 5. So then we go ahead and solve it. We're going to add 37 to each side. So over here, 5 plus 37 would be 42. That canceled out the 37 on the other side. We're going to subtract 2x from each side, so 7x minus 2x would be 5x. Then we're going to divide each side by 5, and we get 8.4. So then we can check it. 8.4 times 2 plus 5 would be 21.8. 7 times 8.4 minus 37 is 21.8. Okay, there are a few check for understanding problems to do. I'll make a short video about how to do those problems as well. Right now, go ahead, try those problems, see how you do, then you can watch the video, check your answers, and get started on the homework.